So this is question 6.27 from our book, and this question asks, we have a 3-liter sample of helium at 0 degrees Celsius and at 1 atmosphere pressure, and that's going to be compressed into a 0.5 liter cylinder. So what pressure will the gas exert in the cylinder at 50 degrees Celsius? So we have 4 different gas laws that we could apply to this question. You will be given the gas laws on your final exam, but the question is, which gas law will you choose? Okay. So the first one we've gone through is Boyle's law, and that is where your temperature is constant. So right off the bat, we can say, no, we aren't going to use Boyle's law because we're actually moving the temperature from 0 degrees to 50 degrees. So we can't use Boyle's law. Charles' law we use when the pressure is constant and the temperature increases. So again, we know that the pressure isn't constant for 2 things. One, it says that we are squeezing our 3-liter sample of helium into a 0.5 liter cylinder. So right off the bat, our pressure is going to increase. The second thing we know why is it's specifically asking us, well, what pressure will that gas be exerted under? So we know that the pressure isn't constant because we already are given pressure 1 of 1 atmosphere. So if the pressure were constant, the question wouldn't be asking that. So the third formula we could use is actually a combination of Boyle's and Charles' law, which is the initial pressure multiplied by the initial volume over the initial temperature is equal to the final pressure multiplied by the final volume over the final temperature. And it says only used when the mass is constant. So nowhere does it indicate to us that the mass of our helium has changed. So we're actually going to use the combination formula. So it's P1 or Pi VI over Ti is equal to P2 or PF multiplied by V2 or VF over T2 or TF, F being final. Now, a few things to remember here. Temperature to us when we're working with our gas laws is always going to have to be used in kelvins. So you have to remember that when we're working in Celsius, we are always adding 273 to that Celsius to get our true Kelvin value. So that's one thing we have to concern ourselves with. The second thing is that the question itself, it's asking for pressure and it doesn't ask for what kind of pressure. So our initial pressure is given to us as atmospheres, but you might have questions that are giving you in torr, and you have to move it into atmospheres or other things, or PSI for instance. So if we were to need to do those conversions, we would give you the conversion units for that. So in terms of this question right now, we don't have to worry about that. So I'm just going to go ahead and plug in the values that we have. So pressure 1, okay, is going to be that 1 atmosphere. Okay, volume 1 is going to be 3 liters, and that's another thing that we need to talk about, is that your volume always will be in liters. So if the question gives you milliliters, you must convert that as well to its liter form. So temperature 1 is 0 degrees Celsius, but again, we need to move that into Kelvin. So 0 plus 273 does give us 273 kelvins, and that will be equal to P2, because that's what we're finding out, what pressure the gas is exerted under. And we're going to multiply that by 0.5 liters because that's our second pressure. And we have a second temperature of 50 degrees. So 50 plus 273 gives us 323. So now what I'm going to do is we can combine our fractions. So we have 1 multiplied by 3, so we have 3 over 273 is equal to 0.5 P2 over 323. So now what I can do is I can actually cross multiply because I have a fraction equaling a fraction. So what we end up getting is 3 multiplied by 323 gives me 969. And then I have 273 multiplied by 0.5 gives me 136.5, but it's still going to be multiplied by that second pressure because we haven't isolated for that yet. So now I'm going to isolate for my second pressure by moving my 136.5 across the equal sign, and that becomes a division. So P2 is actually equal to 7.098, and if we're going to keep it to 2 decimal places, our second pressure is 7.10 atmospheres. So it's pretty interesting. We've taken a 3-liter sample of helium. We've increased the temperature, so that means with our kinetic theory that the molecules are going to want to expand, but because we've compressed them, this is how we've increased the pressure practically 7-fold, because we've gone from 1 atmosphere all the way to 7. So this is just an example of how we would be using the combined gas law.